Now I am going to tell about wage constant, or it can be called as a surface constant. Okay, surface constant. First of all, let's have a look on concept regarding this topic, wage constant. So we are starting with example or question. Question is find out the relation between VA and VB. Figure is something like this. There is an object which is inclined by theta and a rod like this perpendicular to another object. This is also attached. Remember, this is our rod. Theta VW. We are considering this block as a wedge. Okay, wedge. So inclined plane. This is our inclined plane. This is rod, and we are just saying that velocity of this wedge is how much. Okay, and velocity of a rod would be how much? So first of all, try to visualize. This. If inclined plane is fixed with earth, okay, then only rod will move. Am I correct? Yeah. Only rod will move. If wedge is not fixed with earth, then both will move. Yeah. Rod as well wedge. These two things can happen. Question is just asking a relation between VA and VB. So VR, this will be our VR. R means rod and W means wedge. So relation between VR and VW would be what? R and W. Relation. It is asking question. Okay, relation. Now over here you can see. This is giving VW is in this direction, and one component of VR will be downward. Try to understand. Only one component of VW is bringing backward. Only one component, which is VW. And one component of VR is bringing downward. That's why I took one VW and VR. That are valid for this figure. Okay, so both are moving. Resultant would be in this direction. If both move, then you will see a motion will be in this direction. Yeah. So you can you say if this is a 180 degree angle, this will be our theta. If this is theta, you just observe. This is one line, okay, and another line. Both are intersecting. this is theta, can you say that this will be also theta? Can you say? Can you say that this will be also theta? According to corresponding angle. Okay, according to corresponding angle. No. No. This is going to be our theta. If this is theta, this will be our theta. Okay. Look at over here. If this will be theta, so this will be theta. According to this theta, this is our VR cos theta. VR cos theta. And VW will be our sin theta. Okay. Component of this resultant are VR cos theta and VW sin theta. Clear? VR cos theta, VW sin theta. It is asking relationship. So relationship will be VR cos theta, which is equal to VW sin theta, which is equal to VW sin theta. This is the relationship between them, between VR and VW. Okay, relationship means this one component is bringing the rod and second component is bringing backward, which object is a wedge inclined plane. From this sin theta upon cos theta will be our tan theta. So VR is equal to VW and sin upon cos theta will be tan theta. You can tan theta will be our VR upon VW. Am I correct? Yeah, you are correct. This will be our equation for wedge constant. Okay. Now let's take question based on this concept. Question based on this concept. So first question is relation between VA and VB. VA and VB. Figure is something like this. This is figure. One block, another block. This block is moving with a VB. Angle is 53. A block is moving downward with a VA. So we have two blocks, okay, VA and VB. A block is coming downward and VB block is going forward. In this case, what will be the relation between them? One component of VA and another component of VB we have to find. Okay, VB. One component. One downward component and a horizontal component. Vertical component, horizontal component. Relation between VA and VB. First of all, this is our angle. This line. Angle is something 53. Okay, 53. Can you say that this is our VB component? VB. So this will be your VB cos theta. Cos 53. Am I correct? And another component is is a reverse. This is a reverse. I think it should be 90. It should be 90. So 53, 47. Not 47, 37. 37. 37. If this is 53, so from the reference point, this will be also 53. Yeah, we know. This will be also 53. And resultant would be something like this. Resultant would be something like this. Something like this. So remember, this will be also our, if it is making 90 degree angle, 90 degree angle, this will be 37 and this one part will be 53. Okay, 53. 53. Reason is, this is 90, 37 and 90 minus this part will be our 53. From here, this is a perpendicular. So 90 minus 37 will be 53. This V cos VA according to this data, VA will be VA cos 53 and second component is VB sin 53. VB sin 53. This is the relationship. VA cos 53 is equal to VB sin 53. Clear? You can say VA upon VB sin 53 upon cos 53. This is equal to tan 53. So tan 53 is equal to VA upon VB came out as a result. This is our answer. So relation between them is VA and VB. This is our answer. Just put value for tan 53. So tan 53 is considered as a 4 by 3. 4 by 3. VA upon VB. So velocity of VA will be equal to 4 by 3 VB. 4 by 3 VB. This is our answer. Okay. Just see. If this is 53, this was a 53 by the equation. Now we can see on the earth will be also 53 because of corresponding angle. Okay, reason is corresponding angle. Now resultant, this will be our resultant. This one component, second component VA, second component is a vertical and first component is a horizontal. So result would be like this, which is a perpendicular to surface. If this is perpendicular to surface, can you say this will be our 37. Am I correct? Yes, 37. This is 90. If this is a 90, so 53 plus some angle will be equal to 90. 90, 80. Whatever will be value over here, just we will subtract this value from 90, then this part we will get, this part 53. Okay, then you can simplify it further. Your answer will be, there is a relationship between them. Note is component of a velocity. This component of a velocity perpendicular, which is perpendicular to the contact surface. This is a perpendicular from the contact surface of blockage. Yeah, remains the same as the block, so do not lose contact with each other. So over here contact surface will remain same. Okay, without losing contact with each other. Okay, no problem. question. No problem. Next question is relationship between relation between B and U. B and U. Okay. This is one pulley which is fixed by taking one block which is moving with the U velocity, and second block which is attached by two balls by two balls, and it will move with the B velocity. So relation between them will be how much? What will be relation between them? So answer is equal to B is equal to U. This is our answer. Reason is on each points of the string will be same velocity will be same. So over here velocity at this point will be same, at this point will be same, over here will be same. It means what with how much with whatever velocity this block A will also move this second block with the same velocity, okay, when this first block will be released with the some velocities, with the some velocity. Clear? Next relation between V and U. So figure is something, this one which is attached by something, one pulley is fixed, and one string is going downward with V, and the second is taking a block, okay, no problem. Another pulley which is also fixed, it is also taking the same block, and another stick is going downward with the same velocity. So upward will be U. Question is asking with how much velocity this block will go upward, when these two strings will be going downward. Then first of all see, according to this theta, this one component will be our U cos theta. Same this U cos theta will be also for this string. Reason is velocity is the same. We don't care about the components. According to this theta both are same. That's why one component will be same. Don't care about the direction. So whatever force you will apply downward will be also with the same velocity, the block will be going downward. That is what is the main point in this concept. So let's just say I am applying 10 meter per second, okay, 10 meter per second velocity, downward, 5 meter over here, 5 meter over here. Then what will happen? With the same amount, with the same magnitude, this block will go upward, same magnitude. So V will be equal to U sin theta. Remember, this one was this one component is what? This one component is equal to U. you know, this is u. So this one component is equal to u cos theta. This one component is equal to u cos theta. Okay. Velocity which is going upward. So which one component? Which one component? This block. Which one component is bringing the block upward? You would say horizontally component. So horizontal component is u sin theta. Okay. U sin theta. So relation between them is u v is equal to u sin theta. So one component is what? Sin theta. Okay. Sin theta component is going upward, and v u cos theta is going horizontal. But why will you take u cos theta? Is block going horizontally? Answer is no. Block is going vertically. So that's why take u sin theta, and v is a downward. This was a relationship between them. Okay, enough. Now next concept. Next concept. About a spring force. A spring force. This one end of the spring is fixed, is attached. Now it's a time to explore a spring force. A spring force is a force, okay? It is a type of a force. A spring force. Try to see. A spring which is a relaxed, okay? A spring which is a relaxed with having next external force 0. Net external force 0. So that type of situation of a spring will be a relaxed spring. Okay, this is right now relaxed. A relaxed spring where x is 0. X is 0, or you can say displacement is 0. If displacement is 0, it means force is 0. So we didn't apply force, not at all over here. That's why x displacement is 0, or you can say work done is 0. If a displacement is 0, so work done will be also 0. If a force is 0, work done again will be also 0. Try to see. If x is 0, then it means a spring is in rest. Okay, the spring is relaxed. Now next, this same spring, we just compressed. Okay, we just compressed. Force, direction of force will be in this direction. What did we do? We just applied in this direction, so a spring will go inside it. So this displacement will be x will be something, okay, something. So this compression is our displacement. Okay, with how much Newton you compressed, and that displacement will be x. Try to observe over here. We applied force in this direction, so displacement will be opposite in opposite direction. Okay, in opposite direction. You can see this spring wants to gain its original length. Okay, original. So this will go in which direction? Opposite direction. Okay. So x will be our compression. Remember, this was one point. Second point, one was what? A spring will be relaxed, where x will be 0. There will be 0 net external force. Okay. Second is what? After applying force, after pushing the string, x will be our compression. Okay. We applied external force, so there will be a displacement. Okay. So work done will be something. Now another you will see like that a spring. The same spring we are taking. Differences in the second case we just pushed the spring, and in the third case we pulled the spring. This is a difference. Okay. So elongation, in the third case, elongation will be our from here, not from here, but from here till here. This will be our elongation. X is equal to elongation. Okay, this will be x will be equal to elongation. When you are pulling, so you will get elongation. You will get elongation. When a spring will want to gain its original length or original state, then we will say yes, this will restore, the spring will restore the original state. Okay, original state. So over here it will apply restoring force. Okay, restoring force. Also for second case will also apply restore force. Just over here you understood, if you pushed a spring, then it means you compressed, so your displacement will be compression. If you pull a spring, then it means your elongation increased. Elongation increased. Here your force was forward, but a spring force will apply backward. Force. This is what will happen. Your force was back nextward, or you can say forward, but a spring force will be backward, just upward. In the second case, you applied backward force. But a spring will apply forward force, just opposite of your force. Okay. So when a spring force will come into picture, it means it is restoring the force, restoring the original state. Yeah. So this spring force will be our spring force. Clear? Now remember, first point. Let's take first point. Force F changes linearly with x. Okay, with x, and acts in a direction opposite to x, just opposite of a displacement. Okay, then our F will be equal to minus kx. K is a constant, a spring constant. Okay, K is known as a force constant or a spring constant. So K will depend on material of the string. Okay, is a spring metal or non-metal? plastic, whatever. So K is our force constant or a spring constant. Negative sign shows that F is always opposite x. Okay, if displacement is in this direction, so force will be in this direction, opposite direction. If a displacement is in this in back direction, so if a displacement is in backward direction, so force will be uh, forward direction. Okay, forward direction. It's a unit. Unit is what? Newton. Newton meter per. Newton meter per. Newton per meter. Dimension, you know. So our formula would be what? A spring force will be equal to minus Kx, where K is a spring constant. It will depend on material. What is the material? What kind of material is? Okay, and K is X is a displacement. X is a displacement. X is a displacement. Clear? Now let's take equation so that we can understand better, in better way. In better way. This one pulley which is fixed, a spring, it is bringing a globe M2. Over here there is a tension. M2 is moving with acceleration downward, and there is another block. M1. Normal force is upward, and downward will be our MC. This is a tension. So over here we will get M2Z, which is a gravitational force. You can see what would be a spring force by this spring. Okay. There is acceleration. You can't write T is equal to M2Z. You will have to write like that. M2Z minus T is equal to M2A. Am I correct? So for first mass, for M1 will be equal to T is equal to, there is acceleration, T will be equal to M. Here net external force is a T. In backward direction you can say there is no force. Okay, that's a total force is a T, and which is equal to M. For M2, we have a downward force, upward force is a tension. So M2Z minus T will be equal to M2A. Here we can find the value. You can substitute value for T in this second equation. First of all, add this two equation. Okay, add this two equation. This one second. So add both. T will cut to each other. We will get M2Z is equal to A is a constant, A1 plus M2. So you will get value of A, which is equal to M2Z upon M1 total mass. Okay, total mass, which is equal to acceleration. That is M2Z is over here. There is no backward direction. Final force is M2Z. So net external force on the all bodies is how much? M2Z upon total mass is M1 plus M2, which is equal to A. So formula is the same. A is equal to total force upon total mass. Okay, total force upon total mass. And the tension, just to substitute value of A in any equation. So your X will be T upon K. So P is your M1 M2 upon K M1 plus M2 into Z. X is equal to T upon K. We have two objects M1 and M2. We found the displacement by using this formula, which is equal to M1 into M2 into Z. It means M1Z M2Z, M1Z M2Z. Okay, J is a constant, J is a constant upon K M1, K M1. So this K M1 and K M2, K M2 will give us a displacement x, value of x. Now let's take a question based on this concept. Based on a spring force. A spring force. If a given system is in equilibrium, then find out the elongation. Elongation means there is a elongation means pulling force. Okay, stretched displacement. In a spring. Okay, so first figure is this is our string. Which is bringing a mass 1 kg. So K is our 100 Newton. 100 Newton per minute. Per meter. Means in 1 meter 100 Newton. 1 kg. So our mg will be so 10 Newton. mg will be 10 Newton. It is asking if given system is in equilibrium, means velocity is constant. Okay. Then found out elongation in a spring. It is asking x, value of x, and k is a given. So simple formula we will use. Simple formula. F into k into x is equal to ma. M which is equal to 1c. So 1c which is 10. Now over here kx it is nothing but force. Okay, force. So force is equal to kx is equal to ma. So k is a given, which is 100. This is a 10. So our x will be 1 upon 10. 1 upon 10, or you can say 0.1 meter. Displacement is 0.1 meter. Where force was 100 Newton per meter. 100 Newton per meter. Next figure is second question. There is again a spring which is bringing a mass of 2 kg, and K2 is 100 Newton. 100 Newton. So remember, in that case, K formula will be same. K into X M. So total mass K will be our 200. K will be our 200. K2. So this will be our 20. You can write K2 X2 is equal to 2Z. Okay, 2Z. Here X2 will be your 2Z upon K2. But my question is, K2 is how much? You would say K2 is 100. K2 is 100. 1 upon 2, which is 1. But K1 into Kx is of 2Z. 1Z plus 2Z. This 1Z plus 2Z. Both force we will take. 1Z plus 2Z. So 1Z plus 2Z will be our 3Z. Okay. Total force downward 3Z. 3. So our answer will be 3 by 2. 0.3 meter. 0.3 meter is our X2. This is our answer. X2. A spring force was given, and just we calculated X2, which is 0.3 meter. 0.3 meter. K2 into K2 K into X is equal to M. Okay. Over here, total force downward is how much? This mg. 10 plus 20, 30 upon. Final K2 is how much? We are finding this K2 for this system. So K2 is 100. Just put K2, we will get X2 value of X2. Value of X2. Now next question. Next question is, Next question. Elongation. There are two cases. Case number one, case number two. What's the difference between them? Just acceleration. Acceleration is upward and acceleration is downward. This is the usual difference between them. Everything is same except as a direction of the acceleration. Even magnitude of acceleration is the same, but the direction, only direction is changed. So case number one, you will see result of changing direction. Result of a changing direction. So first is, you know, kx is equal to m or total mass into acceleration. So ma, mc plus ma. Look at over here. We are finding a spring force. Okay. So can you write kx minus mg? Case a spring force is upward. A spring force is upward. So kx minus mg will be equal to ma. This came from where? Kx minus mg is equal to ma. Means net external force minus net external force is equal to ma. Okay. Kx is a force. Okay. So mg is a downward. Kx is upward according to acceleration. Over here, k is a given which is 100 and x is not given. Mg is a 10 and acceleration is 2, m is 1. You can find x. You can find elongation. Pulling upward. So your elongation will be first case. Kx is equal to mg plus m. Okay. Over here, m is constant. You can say m is a constant. G plus a. It is showing that direction is upward. Direction of acceleration is upward. Just put a value of each variable. So m is a 1, c is a 10, and a is a 2. K is a 100. You will get x. 1 into 12 upon 100. 6 2 is a 52 is a 25. So 1 upon 25. X is a 1 upon 25. 12 upon 100, which is equal to 0.12 meter. This is your x. This is your elongation. Okay, elongation, not elongation. Elongation. 4-second case. Right? Everything will be changed. Everything will be same, except sign. Kx is equal to mg minus a. Am I correct? Yeah. So x will be equal to m g minus a upon k. K is a given, x is not given. M is a k, 1, g is a 10, a is a 2, k is a 100. 1 minus 8 upon 100. 4 2 is a 25 to 52 is a 52 is a 100. 2 to the 4 25. 6 to the. This was 6 to the. 3 to the 6, 50 to the. So 3 upon 5. 3 upon 5. So 2 upon 25. 2 upon 25 will be our x. X is 0.8 meter. This is our x. X elongation. Okay, elongation. Total external force is equal to M. Is equal to M. Now next question. Next question is, there is a one string, not a string, but a spring. There is a one spring. It is hanging a mass. It is hanging a mass. Whose mass is 10 kg. 10 kg. This is our spring. A spring tension will be over here. And second figure is something like this. Again a string. Again a string. Who is hanging? A mass 10 kg. S2, S1. And third is, this is a vertical and third is a horizontal. A spring will be horizontally. A spring will be horizontal. The same mass. So mass is 10 kg. We have to see difference between them. What's the difference? Mass is same. Just you will see, it has a 1 spring, it has a 2 spring, it has a 3 spring, 2 spring. But second is a vertically and third is a horizontal. Okay, parallel combination or series combination you will see from here. You will get parallel combination and for first simple formula. Simple formula. You have to tell reading of a spring balance. Reading of a spring. So reading of a spring will be T is equal to 10 kg. Reason is there is a no acceleration. That's why T will be equal to 10 kg. Okay, 10 kg. Or you can say, you can convert this kg into a spring balance. 10 kg WT. So reading of a spring will be your 10 kg WT. Okay, WT. For second case, There are two springs, S1, S2. So for second, you are getting 2T. This 2T. T1 and T2. So your 2T will be equal to 10Z. This 10Z. This were our 10Z. 10Z and 10Z. Kilogram watt hour. Now this right now we have two springs, so tension will be 2. 2T is equal to 10Z. Is 10 multiple Z. Mass is there is only one object whose mass is 10. That's why only we are taking 10. 10Z. 10 multiple 10, 20, 20 mg. It is saying this is equal to 10Z. So T will come out as a 5Z. So over here T is how much? 15 Newton. Okay. T is how much? 15 Newton. So reading of a spring will be 5 kg. Just convert G into kg watt. So reading of a spring will be, just convert 5G into G into kg. So your reading of a spring will be 5 kg kilowatt. 5 kg kilowatt. Clear? This will be your reading a spring. Reading a spring. Now look at over. We were talking about the second case. So second case, T is equal to, we are talking about this is a T tension. So T will be equal to 10Z. Till here, are we correct? T will be equal to 10Z. This is value of tension. So tension will be your 100 Newton. Am I correct? Tension will be 100 Newton. Just convert this 100 Newton into kg. So your reading of a spring will be your 10 kg Wt. 10 kg Wt. Don't convert Z into number. Okay, J should remain. Just put Z as it. Put Z as it. Don't convert it into number. Now for third case, we have 2T. This 1T, this T. So this will be added. This will be 2T. And 10 multiple Z, 10Z. There is only one object. But two springs are hanging only one mass. Only one force, which is 10G. So that's why 2 tension will be equal to 10Z. Over here, T will be your 5Z. You can say reading of a spring will be 5 kg Wt. Am I correct? 5 kg Wt. That is how you will find a reading of a spring. Now main points for this concept is, write in this section of a note. When a spring balance are connected, you can see this was connected vertically and this horizontally. So in a note is, when a spring balance are connected in series. This is a series, I think so. Then the reading of each balance is the same. This will be series, okay. Reading balance will be same. For example, reading of a spring was 10 kg WT. So this will be over here. S1 will also show 10 kg WT. Okay, S2 will also show 10 kg. If springs are connected in series, okay, in series. When a spring balance are connected in parallel, like this, but these are parallel. Okay, these are parallel. If both are parallel, just we will divide by 2. By 2. By total spring, yeah, total number of spring. Then the reading of each balance is the same and given by reading is equal to applied load by number of spring balance. So there were two number of spring balance and load of this object was 10 g. So 10 g upon number of spring balance. Then our reading of spring came out as a 5 kg. 5 kg. Clear? Clear? Again. If in series, then each balance, reading of each balance is the same. Okay, each balance is the same. Here it is saying so 5 kg will be shown by first spring, and the same amount will be shown by second. So each spring will show same amount 5 kg. But when it comes to in series, then 10 kg will be also for first and second. Just understand, when parallel series will come, parallel, then you just divide total load by total amount number of spring bar. That's it. Your answer will come out.